Sometimes you have several ions in a certain solution. So for example, let's say we have a container, and this container has calcium ions, has magnesium ions, maybe sometimes it has let's say silver ions. So what you want to do is to collect each of these ions one by one. To do that, you can use the KSPs and the solubility equations to determine which one will come out first, or which one is the most soluble. So KSP is really important for separating two or more cations from a solution. Let's look at an example that will give us an idea how this is done. We have a solution that is 0.0059 molar of magnesium and 0.011 molar of calcium. So if we use sodium hydroxide to provide the OH ion, an ion that is, which cation precipitate first? So what we do is we deal with these cations one by one. So first, let me deal with the magnesium. So the magnesium here, we start with the equation, the solubility equation. Magnesium hydroxide, solid, to form magnesium cation and hydroxide anion. And then the KSP for this, normally I'll give you the KSP. The KSP for this is 2.06 times 10 to the power negative 13. So what we want to do, we want to determine at what concentration of sodium hydroxide is this going to precipitate. So we want to determine at what concentration of sodium hydroxide is this going to precipitate. Now, for this equation, the KSP is given by Mg2 plus OH minus squared. Now, we are given the concentration. The concentration of Mg2 plus is already given, which is 0.059 molar. So we just substitute this concentration and put it here. So what do we have? We have 0.059 times the concentration of OH squared is equal to the KSP, negative 13. Which means the hydroxide concentration is equal to the square root of 2.06 times 10 to the power negative 13 divided by 0.059. So this is equal to 1.9 times 10 to the power negative 6 molar. So we say that the precipitation occurs when the concentration of sodium hydroxide is 1.9 times 10 to the power negative 6 molar. Now let us compare this, and first let me get rid of this here. So let us compare this with the calcium and see which one is bigger. So if we take calcium, we'll start with an equation also. The calcium hydroxide solid will form calcium ion aqueous and the two hydroxide ions, which is also aqueous. The KSP of this, which will be provided, the KSP is 4.68 times 10 to the power negative 6. We are already given, we know that the concentration of calcium is given as 0.011 molar. And the KSP is calcium and OH squared, which is 4.68 times 10 to the power negative 6. By substituting 0.011 times OH squared is equal to 4.68 times 10 to the power negative 6. So the concentration of calcium, or of the hydroxide ion, is equal to the square root of 4.68 times 10 to the power negative 6 divided by 0.011, which is 0.021 molar. So what does it mean? Calcium ion will precipitate when the concentration of the hydroxide ion is 0.021 molar. What does this mean? So again, magnesium precipitate at 1.9 times 10 to the power negative 6 mole. Calcium precipitate at OH 0.021 molar. What this means is, if you are using OH, the magnesium will need very little OH to precipitate compared to calcium, which needs a lot of OH. So this implies magnesium needs I'll just say magnesium needs less OH to precipitate than calcium needs. This implies magnesium precipitates first. So if you want to separate these solutions, just add sodium hydroxide to the solution. Magnesium will come out first, and then later on you can collect the calcium. So these are the equations that we are going to talk about in terms of solubility. Make sure that you complete the video assignment for this. Thank you.